Hello guys, welcome to this Golang course again. Abdu here again. Alright, so today we're going to learn more about user-defined type struct and also embedded struct and interface and also reflect function. Okay, but first, back to yesterday's lesson about strings. There is also like a great function. I forgot to mention it's called equal fold. Okay. Let's see. Nope. Hold on. Okay, and then strings dot equal fold. Okay. Remember also yesterday I explained how functions are case sensitive. Okay. Well, equal fold is the opposite. Equal fold is case insensitive. Okay, let's try. Let's say hello. Okay, and then let's say again hello. Okay, like this. 1 second. Okay, let's run it. Okay, great. And right now you can see here it says true. Okay, even though like the first hello is all in capital letters and the second hello is in you see, if we also do like this, hold on, let's say L and here like small also, and we do like this, it's still gonna show us true. Okay, but for example, if we added like another O here, okay, if they don't match, okay, so you need to understand what case sensitive means. The case sensitive means is just it's gonna ignore, for example, let's say if anything is like case let's say capital letters or like lower cases, it's gonna compare the letters. Here there is H, there is H, E, there is E, there is double L, there is double L, there is O, there is O. Okay, and then it's gonna show you like true. Okay, if you also add here like space, remember space is a character. Okay, so space and then like 1, it's still gonna show us true. Okay, because they compare, they are identical. All right, so that's it for this function. Okay, so back to struct. Okay, we can use struct if we want to create our own data type. Okay, there is data type strings, there is integer, float, boolean, okay, etc. There's but sometimes, you know, we need to create our own data type. Okay, we have type. Okay, hold on. Remember we used struct on like I guess on the lesson before the last when we created the API with Go. Okay, there is type. Okay, in type has like a group of properties. Okay, that's ours. Okay, I'm gonna show you in details. Okay, first we use type and then type is like data type. Okay, and let's say student. Okay, and the student is the name of our data type, and then struct. Okay, like structure, and here. Okay, and remember last time when we did this like with the APIs, we put in like what we wanted to collect. Okay, so say name and we want it to be a string, and what else? Let's say age, an integer, and let's say department, and we want it to be a string. Okay, great. Right now if we go here, hold on, yeah, okay, right now we have like a data type. Okay, so right now we need to define like a variable. Let's call it like by name. Okay, and let's say equal. Okay, and then student, and then there is name. What is the name? Let's say Dave. Okay, and there is age, it's an integer, let's say 29, and there is say department, let's say IT. Okay, okay, you can see here there is like 3 values. Okay, but like in the memory there is like only one thing that's going to be defined. It's the student. Okay, so it's going to take only one place in the memory instead of like 3, okay, or 4. Okay, right now I'm going to say if empty print line. Okay, and then we're going to use by name. All right, let's print. let's run our app. Okay, you can see here it says name, age, and department, Dave 29 IT. Okay, we can also like go inside like this struct, okay, and for example take something like specific. Let's say name or age or department. Okay, let's say let's say name. Okay, and we print, and then it's gonna say it's gonna take the name only. Okay, and you can also do the same like with age or with department or anything. Let's say department. Okay, it's gonna print IT. Okay, if we also take it here and change it to age, it's gonna print the age. Alright, so this way like struct can really help us. Okay, we can also like, for example, let's say take data, okay, and put it like inside struct like this. Okay, and then we can sort it. Okay, and for example, let's say we can use it, let's say, to count how many students we have, let's say, for this course. Okay, and save it inside, okay, like this. All right, we can also use like a struct inside another struct. Okay, and it's called embedded struct. Okay, let's leave student, and what should we make? Actually, there's actually one thing actually I've been meaning actually to say for a very long time. It's about like there is like some good developers that say that the address should be a string. Okay, but the address shouldn't be a string. Okay, the address should also be like a structure. Okay, its own struct, and I will tell you why. Okay, let's go down here, and then let's say type, and then we say address. Okay, call it address, and then struct. Okay, and because in the address there's a lot of information. Let's say first straight number. Okay, an integer, straight name, and we want it to be a string. Okay, and what else? No, let's say a city. Okay, and let's say a string, and then phone phone number, and we want it to be an integer. Okay, and then we can go here and let's remove the data type. Okay, because the address, it's its own structure. Okay, it's a data type, so it doesn't need data type here. Okay, so you can see here, hold on, the address. Okay, for example, all these parts, okay, are part of the address, so you shouldn't create a variable, okay, like we did here, and inside the struct, and then call it address, and then say it's a string. Okay, but you can do like this, like we did right now, and like this you can add everything you want to collect inside the struct. Okay, okay, so right now you can see here that we put a struct inside a struct. This is called embedded struct. Okay, because it's its own struct, and we put it inside another struct. Okay, and remember, no data type. Okay, so right now you see we can collect the name, age, department, and the address. Okay, and this doesn't affect like any of these structures. Okay, they will work just fine. All right, we can also do let's go here and say or why, let's just say var by address. Okay, and then we're gonna say address, just like with the student. Okay, okay, street number first, and it's an integer, let's say 1 2 3. Okay, and then street name, and it's a string, let's say Central Avenue, and for city, it's also a string, let's say Brooklyn. okay, and then phone number, and then we're gonna say it's an integer, so just blah blah blah. Okay, like this, and then we're gonna go here. Let's remove these two, okay, and then we're gonna say by address, okay, and then let's print. Okay, you can see here right now it says 123 Central Avenue, Brooklyn, and then the phone number. Okay. All right. Let's see. What's next? All right. We can also do like this. Hold on. No, it's address and then by address. Okay, the first address it's the name, okay, of our struct, and by address it's the variable we made here. So right now we need to copy this one, okay, and put it under like here, okay, and then let's run our app. Okay, you can see here it says it shows like first this like the student, okay, and then the address, okay, because it's a struct, so it's inside its own object. We can also do like this. Hold on, address, and remove this, and we say address, and then open an object. Okay, let me just copy this, okay, and we can put like this inside it. Hold on, yeah, okay, like this, and then let's put it inside. Okay, see, right now, so we don't need this one anymore. Okay, let's comment it, okay, like this, and let's comment this one too. Okay, no, hold on, my bad. All right, when we print by name here, you see it's still the same, okay, even though like we disabled by address, and also like when print line by address. So you see, just like this way, there is two ways, of course. You see, you can do this like the way I showed you before, okay, and this way. If you already like define like let's say by address, so you know, I guess it will just save you like a little time instead of writing it there. So you can just use like address, and here like by address, okay, without any of this we did here. Okay, great. All right, so we can also use them like with with functions. Okay, let's try. Let's create a function here, and what should we call it? There's a variable, okay, called s, and then say that it belongs to the student struct, okay, and then call it print info, okay. Okay, right now we want to make it executable, okay, print line, and then we're gonna say actually you don't have to do this, you know, okay, you can just put here like s, okay, the variable we define here. But for me, you know, let's just say from what? From the student like function, okay. Okay, and like this, see, and then we're gonna go down here, and we're gonna say by name, okay, dot, and then print I don't know, yeah, it is print info. Okay, let's run it right now. Okay, great. You see right now it says from the student function. Okay, we just like put in like this from the student function just to make sure that it's coming from that function, okay, not from somewhere else. From the student function, and then you see it prints our data here. Okay. Let's say Okay, and here you see we used by name because also by name belongs to student, okay, and this function belongs to students. So you see here we use them together. Okay, so you can use them like this way, okay, and you can also use like this for the address, okay. Just remember that like these functions are dynamic, so you don't like need to call it and use if empty print and print it, okay, like format print. Just, you know, the variable name, okay, like we did here, and then the function, okay. All right. Let's see what's next in there. All right, so yeah, all right, so this is it for the struct, okay. Let me remove this. All right, right now let's move to reflect and interface, okay. But let's do like interface first and then reflect, okay. All right, so in Go you will find like word interface, okay. You will find interface like a lot in object-oriented programming languages, okay. But remember what I said before, that you have to keep in mind that Go is not fully an object-oriented programming language, okay. Only those like who have interface and inheritance, okay, that are like object-oriented programming languages. But Go, like I mentioned before, also is similar, okay. Go supports inheritance like by embedding struct like we saw before, or by using like interface. So I showed you how to use embedded struct. Right now I will show you how to use interface, okay. And the interface acts like an object, okay. And we know that, you know, there is no classes inside Go, okay. So using interface, we can use like functions that works as an interface, okay, that doesn't have current rule, okay, but later like we can define its role or value, like we saw with the S and student function like print info. All right, so for example, if we like came here, okay, let's go again, and we say okay, and like we create an interface, okay, by using type, okay, and then we say let's call our like interface geek, okay, and then interface, you see, just like a struct, okay, and let's create here, let's say coding. Okay, you can see here I didn't use like func, okay, or variable at the start, meaning that it's an incomplete like function, okay. There is like a name for it, okay, and it's called an abstract, okay, abstract. So this function is incomplete because I didn't set what it's going to do, okay. Or, you know, or its rule, so it's like incomplete or inactive. All right, so let's go create like its function right now. We're gonna say func, and let's say print info, okay, and let's create again a variable that we can use later, and then say that it belongs to geek, okay. All right. Right now I want it to be again executable, so say print line, okay, and say just print G, okay. Let's not put any text inside it this time. All right, let's see. Okay, so now that we create like an external like function, okay, in its role or job, okay, is to take the interface and print the info of the struct, okay. We will make right now, okay. What should we call it again? Let's say nerd and struct, okay. And what we want to collect, let's just say name, okay, string, and the department, and also want to be a string. Okay, and then we're going to create another function for nerd, and we're going to say func, and then c again as a variable that we're going to use later, and then nerd. Hold on. Say this belongs to then like the function nerd. Okay, and that's such an absurd name. Okay, anyway, and then let's say print print nerd. Yeah, this is just fine. Okay, great. And also want to make it like executable. Okay, and then we say if empty like format print line, what should just say I am a senior no nerd. Okay, what else? Same way. Okay, if we created another struct, let's say type, and then we say what should we, let's call it junior geek. Okay, and then we're gonna say struct, just like the same with the one on the top. Let's call it the same thing, string, and also a string, department also a string, and let's create again its function. It's the same thing here. Okay, so just copy it, and here let's remove and say g and say gr geek. Okay, that just this belongs to like junior geek, and then here we say, let's just say geek. Okay, and here we say junior yeah, geek. All right. Okay, yeah, okay. Right now let's put them like inside the main function. Okay, let's say var, and then we use like hold on here, C for nerd. Okay, just use n, so it would be like easy to remember. Let's say n, and then we say equal what should this equal? Okay, equals nerd, and then name it's a string. What should we say? Dave. Okay, and then there is department, and then we say department is what should we call? Let's just say IT again. Okay, and let's do the same for, let's say here IT slash cyber, and here Dave, let's call it Brian, and here we say junior geek, and here G. Okay, okay, right now let's say okay, we're gonna use n, okay, dot, because remember here, and then we'll call the name of our functions. The first is like we call it print, yes, print nerd. Okay, the second is what is the second? I think it's just print geek. Yeah, okay, let's check. Yeah, it's print geek. Okay, and here you see we use the variable, and then we wanted to print the info inside like geek. Okay, and this is the info of junior geek, and then let's run our app, and here you can say it says I'm a senior nerd, I'm a junior geek. Okay, see everything we wrote here. Okay, all right, so this way like we can print it. Okay, like if we want like to execute like the function of, okay, like nerd or geek. Okay, or like I mean junior geek. Okay, and how can we can we use the interface right now? Okay, so nerd and like junior geek, okay, belongs to the geek interface, okay, and they go through geek's function, okay. So now we can make nerd and junior geek, okay, and junior geek go inside it, okay, go inside geeks interface, okay, and get its info, okay, and we can use like print info because print info function accepts like struct, okay. So let's go here and say print info, no, hold on, and then we say n, and here we say no, let's go back and the same thing and say g, okay. And right now we need to go back up there. First, wait, let me show you. Okay, see here right now it says we have a problem with implementation, okay. So why like it doesn't like do implementation? That's because here wait, here we have an incomplete or abstract function, okay, called coding, and we forgot to use it, okay. So interface cannot use any functions that belong to it as long as you are not using like the struct inside it, which is or the function inside it, which is in our situation it's called coding, okay. The solution is very simple. You know, instead of like print nerd, we can use we can replace it, hold on, here with like coding, and here we can also use, hold on, coding, the same with like, okay, nerd coding, okay. And let's remove these, we'll just comment them. All right, right now let's run. Okay, see right now it prints both Dave and Brian, okay. Okay, we can also do it this way, like let's say n dot, hold on, coding. See, you see, this way it's like way simpler. We can use like one function for all of them, okay. So this actually saves like a lot of time. Let's say also here coding, okay, and let's run it again. See, I'm a senior nerd, I'm a junior geek, okay. So this is actually really amazing, okay, because it helps a lot, okay. And also you know, because we used coding in more than one place, okay, so I don't need like to do a compile, okay, to all these functions, okay. Only one function, which is coding, okay. Because even though like coding belongs to like interface, you know, but here let's go down, yeah, okay, where is it, yeah, okay, but here, okay, for like in junior function, okay, we'll like leave the info of like we'll leave the info of junior geek here, okay, and also the info of junior nerd here, okay. And here, hold on, let's go down. In here like G and N, that's coding, okay. I was able like to use coding like in two structs, even though like I only defined it once in our interface. And like above, like with the print info, I was able like to take those these objects, okay, through print info function and display the info of nerd and also junior geek, okay. I hope that's like understandable enough, okay. So let me repeat again, because I think I made probably like the last thing, like not okay. So what we did here, okay, is that like I mentioned, coding belongs to the interface, okay, but we were able to use it like for the function like of nerd, okay, which means in the function like nerd belongs to nerd, okay, and junior geek here, okay, we also use like coding function, but it belongs to the junior geek struct, okay. And here you see like when we left like the info that we wanted to collect, which, you know, we put them here, okay, and it goes like all this info, okay, goes through our interface, okay, our interface and its function, because like I mentioned before, print info accepts structs, okay. And by that I don't mean like print info is like some kind of I don't know, like library or something, because we can just change it to, I don't know, anything like this and then use it down here, okay. So I'm just giving you like an example. All right, so there is also like a great library in Go, okay, called Reflect. And remember we used it like on one of our lessons before, okay. Reflect is very useful. We used Reflect I think on yesterday's lesson, like about strings. Reflect is very useful like to know the data of the data type of the variable, okay. Like for example, okay, first let's remove everything here. Let's remove everything here, okay. Okay, first thing, you know, we need to import like the library here, but again I'm using Golang, so you know it helps because it imports everything for me. Okay, let's say num, and then we can use here like the shorthand and say 33, and let's say num2. Let's also use like shorthand and say equal what? Let's say true, and we say num3 shorthand again and say equal something, and then we're gonna use ifmt. Okay, print line, and then we're gonna say reflect dot type of, okay, and then we're gonna say num1. No, there's no num, it's just num, okay. And then let's okay, and then num2, and there is num3. Let's create another one. Let's call it num4, and we say 33.9, okay. Okay, let's go here also and say num4, okay. Okay, right now let's run our app one more time. Okay, you can see here the first one says it's an integer, the second it's a float, the third is a boolean because you say it's true, and the fourth is a string, okay. If we change this one also to false, it's still gonna show us the same. Alright, see, it's still a boolean. Okay, so we can use reflect like to get the data type of variables, okay. And remember that reflect like gives you like the data type during like the runtime, okay. Meaning when the app like you know, we just like clicked on like run, okay, the app will ask the memory and then knows exactly which data type is that, okay, before even like the display, of course. Alright, so I think that's enough for today. Again, we took like more than half an hour. Alright guys, please, if you don't really understand anything, make sure please like to leave the comment, you know, so I can make sure that next time, you know, I can explain them like in more detail so you can understand well, because it matters to me. And also like if there's like some course that you really want like to learn, just let me know. I'll make sure if that's something, well, I know like a lot about, I'll make sure to drop it in like to upload it like to YouTube when I get some time. Alright guys, so that's it for today. See you in the next one.